Finally, the video you've all been waiting for. Today, we're gonna mint ourselves compressed NFTs. Welcome to another Solana tutorial. Now, last time I said that I would, have a look at how to mint compressed NFTs until the next video. I did not do that, but it's much more fun to learn it together anyway. It's just gonna take me longer, but that's a problem of my editor, who has to cut all of that out.
Well, thank you.
Okay, let's go. Where do we start? I mean, there are enough resources out there where they do compressed NFT mints. So we're just gonna have a look at that and then learn from it and then do it ourselves. Easy as that. That's how you develop. You just check out other stuff and then based on that, build your own stuff. Welcome to software development. Okay, so this 1 million NFT page, 1 million NFTs dot page, has a canvas of 1,000 by 1,000, which is a million. And you can mint an NFT by just clicking, like I already did up here. Point is, we do have the source code for this, so we can just go check it out. I'm just gonna clone it. So, what do we have here? Canvas, my pixel, wallet, mint. Okay, so here we have the arguments. So that's the metadata of the NFT. And there's the important stuff. Create mint to collection v1 instruction, where we have all of those arguments. Pretty self-explanatory, most of them. That thing, of course, already expects the tree there, the merkle tree. Before we can do that, we obviously need to create the merkle tree. Where do you come from? From Metaplex Foundation, MPL bubblegum. Let's check this Metaplex MPL bubblegum. Maybe the docs on that are somewhat helpful. Okay, that's part of the Metaplex program library, and there we have bubblegum. So we have the program and the JavaScript part, API docs. Okay, I mean, that's not quite what I want. But okay, all the instructions are also helpful. But I still need to find out what is the order in which to call them. Mint, compress, send and verify, transfer, unverified. So yeah, that's the things that we want to do. We want to mint and transfer today. I'm going to refer to that once I want to know how to call them. But first, I want to find out which ones to call. How it works, program overview, has not been formally audited. Use in production at your own risk. So with bubblegum, we can create a tree. So we create a tree also through bubblegum. That will then use the SPL account compression program, I assume. Mint a compressed NFT to a tree. That's what we want to do. And then transfer the NFT. We can burn an NFT and we can redeem an NFT and decompress it into a normal NFT. So the goal for today is to do the necessary things in order to then mint and transfer an NFT. That's my goal for today. All right, background. Well, we talked about this. Uncompressed, they're on chain in accounts and compressed, encoded into a merkle tree. Don't put it in the state, just put it in the ledger. This state is, they refer to something different again. The state of the NFT. Anyway, compressed NFTs are secured on chain by hashing the state data. So that's the NFT data that we're talking about here in state. All those words are so confusing because they have so many meanings all the time. How should somebody ever understand all of this? Well, by watching all my videos and learning a lot. Continuously learning. Compressed NFTs can also be losslessly decompressed into an uncompressed Metaplex NFT. But then you have to pay the cost for rent. So, creating and minting a tree. Well, I mean, should we just do this? Let's start by creating a tree. Create tree. This instruction creates a merkle tree. And it needs those accounts and these arguments. Fairly straightforward. We got the docs. We got the docs. Create tree. And we're gonna npm I Metaplex MPL bubblegum. Let's go. There we go, easy. And then let's get a wallet. cNFT. There we go. We go to DevNet to start with because it's easier to get funds there. And my key is this cNFT. Airdrop myself to Sol. And then we see if we can find the create tree instruction. Import from. There we go. It even suggests that. How easy is that? Create burn instruction, create tree. Yes, that's what I need. There, create tree. Boom. That's what we need. And then a function. And I mean, I need the usual quick little function just to load key pairs, because that's always the same and I always have to copy it. So that's my key pair. And I need a connection, of course. I'm too lazy. There we go. With the key, we have the connection. What else do we need? I'm also getting lazy now and I don't even put semicolons anymore. At least I'm now being consistent. No, I'm not being consistent. Stupid ADHD. What am I doing? Let's see what this create instruction needs. Create tree instruction. What you need accounts and arguments. Oh, who would have thought? Okay, accounts. Compression program. Log wrapper, merkle tree. Pair, tree authority, tree. All right. So the compression program is probably the SPL account compression program. SPL account compression program ID. That's in Solana SPL account compression. We know this. Okay, next. The log wrapper. I think that's the no op program, right? SPL no op program ID. Boom. What else? The merkle tree. You know what? Let's read the docs. I mean, I can make more assumptions here, or just read docs. Let's read docs. So there, compression program, SPL account compression program ID. There we go. System program ID. There we go. Log wrapper, no op program ID. So far I was correct. Now the merkle tree account that will contain the merkle tree will contain. Sounds like a new address. I could do it like this, just a new key pair, but I love myself some vanity, so Solana keygen grind a tree. It starts with T-R-E. Tree. The T-R-E. That's another song. Ding 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 is the T-R-E. Come on, find me a T-R-E. Better chances with ignoring case. There we go. It's the T-R-E-Z. We got a tree. There we go. This guy. Now, back to the merkle tree will be merkle tree. Then, the tree authority. The tree config PDA account that is initialized by this instruction. Okay, what's a tree config PDA account? Tree config. Do you tell me how you derived or something? It's a PDA, so it is derived somehow. Maybe it's in there. Get. Find. Accounts, tree authority. The tree authority PDA account stores information about the merkle tree. Account data is represented by the tree config struct. Yes, okay, that's what's in there, but then you still didn't tell me how to derive it. I need the seeds, please. We have an owner of the merkle tree, with a delegate authority, and we have a number minted to keep track of the NFTs minted in a tree. Okay, that makes sense. But still, are there some tests anywhere? Because from tests we can usually derive a lot. Create tree instruction there. Tree authority, and the tree authority, thank you, there it is derived with the merkle tree. That's it. It's literally just the merkle tree and the bubblegum program ID. Simple enough. I take it. I mean, those things would do well in documentation, just saying. But I find it because I'm a pro, yo. And I teach you how to do it too. Woohoo. Back to work. Stop trying to be funny. Okay. The tree authority, and we ignore the bump, is public key. So this stuff is deprecated. That's where Jonas got it from. We do it in sync, so we don't need to await, and then it's not deprecated. Merkle tree to buffer doesn't exist on key pair. That's true. So this is just a public key. Merkle tree public key to buffer. Oh, true story. Then I also need the public key here, of course. And the bubblegum program ID. We import that. We can't import that. It must be somewhere. Program ID is bubblegum program ID. Okay, so we have the bubblegum program ID, and we have the stuff, and we have the tree authority. Then we can put the tree authority in here as well. Isn't that nice? Next up, I mean, it's pretty easy, all of it, right? We'll see. I'll make that statement again once it works. Payer. Well, that should be fairly obvious. The guy who's paying, and this is my key pair. So the payer is my key pair public key. Next, the tree creator. Well, that's also me. The creator owner of the Merkle tree. I'll keep it. I'll own it. Tree creator is also me. Me, all me. And this and this and this. I can also put the system program. This seems optional here, but I'll do it anyway for completeness. Now, what else? Those were the accounts. Now come the arguments. Arguments, you need a max buffer size, a max depth, and public. So arguments, max depth, and max buffer size. Interestingly, it doesn't let me specify the canopy depth. I would have also expected it to let me specify canopy depth, because those three elements is essentially what make up the Merkle tree, and the bigger the canopy, the smaller needs to be the proof. Oh, maybe they automatically set the canopy to the ideal number such that we can still use it without having too large transactions, but also allowing for minimum space requirement. Could be, and could read source on that, but let's not. For now, let's just create a tree as bubblegum would do it for us. So max depth, this is important for, well, how many NFTs do we want to mint with that tree? And maybe while we talk about that, it is not necessary to have all the NFTs of one collection in one tree. You can have several trees for one collection. You can also have one tree for several collections, but that doesn't make so much sense. I don't really see the use case in that. For me personally, it's nicer to split them into several trees if you have different collections. However, having several trees for one collection makes sense, because in one tree, we're limited with concurrent writes. If you watch my video on account compression, we know that we use concurrent Merkle trees, but they are also limited with the max buffer size on concurrent writes. So we're limited in how many transfers or new mints we can do at the same time. And depending on how, popular your collection is, that could lead to problems if everybody wants to, transfer at the same time. And if you have several trees, then you get that multiplied. If you have several trees, then obviously they are independent from each other. So all the NFTs in the one tree are not blocked at all if NFTs in the other tree are used. So those are the arguments that we're working with here, right? How many NFTs do we want in that tree, and how many should be able to be moved in the same, I think it's not even block, it's in the same, no, it's not slot. What is the smaller within one slot? There are also, Solana basics. There was another thing. Well, okay, maybe I misremember that, and it is the slot. I don't know. So definitely between two slots, you have the full concurrency again, but within one slot, you're limited to the max buffer size in writes to the tree. And don't quote me on slot, it might be a smaller, I'm not sure. Damn it, I wish I could find that out somehow. Point is, how many NFTs do we want in a tree? And how many concurrent writes do we want to support? And also those values are linked, as we saw last time. You need to have a certain buffer size for a certain depth. For instructions on enabling the canopy, see canopy. Interesting. Anyhow, for our first tree, I don't know, how many NFTs do we want? We're indefinite, we have money. Well, how about like a few thousand, 10K? 10K so that it makes sense. So we want a collection of 10K, let's say. Log 2 of 10K. 13.2. So 2 to the power of 14 gives me more than 10K. So we need a depth of 14. My max depth is 14. And then my buffer size. Well, how many concurrent is that? I don't know. What are the values? Oh, there's a depth size pair. That's convenient. So I don't need to look that up myself. Where did they get that from? Valid depth size pair from the SBL account compression. So let's also get ourselves a depth size pair, which is supposed to be a valid depth size pair. And then it suggests us, hopefully, let's import that. And now it suggests, max buffer size and, oh, wow. And there it, wait. If I first put the max depth and set it to 14, then the max buffer size presumably is any of those, right? So that's pretty cool. That's pretty cool. There, all the possible values are given. So do I want 1,000 concurrent writes per slot? Do I want 2K, 500,000, or just 8? I mean, we are on DevNet, so really I don't care about my sol, so I can be like, yeah, I want 2,000 or like 1,000. It doesn't really matter. I could also go with just 8 because there will not be so many writes on my... Oh, wait, but then it's illegal. Hold on. Oh, no, that's not even a legal pair. Okay, so it's... the suggestion is not as good as I hoped it would be. So apparently this is not a legal pair. Here we see the legal pairs. So let's go for depth 14. We have 64, 256, 124. So for 14 we have those. Interesting how 512 is not among them. Okay, but yeah, those are our possibilities. Yeah, but 64 should definitely be enough. Let's take 64 and be good with it. So that's a valid pair now. Sweet. And then down here, just from my pair, take the max depth and the max buffer size. Cool. So nice to just look at tests. Okay, what else? So apparently this also needs the public, which I don't know what that is. Oh, just false. I mean, I would imagine that means something like if it's public, then anybody can just use the tree to mint NFTs. But I certainly don't want that. I want my tree to be private. So only the tree authority can mint. I think that's that. I didn't see it anywhere in the docs. Oh, there is also no public. So that apparently says older version. So yeah, let's just go with false because we want to just be able to mint ourselves. And that's pretty much all the code we need for creating ourselves a tree, I think. Well, we have the instruction. Now we also need to, send it and stuff. That should be fairly obvious because we know how to do that. If we get back a transaction instruction, then we can just put it in a transaction and send it out to the network. We totally know how to do that. The instruction goes into a new transaction. Oh, come on, type correctly. There it goes. And then we just send it. This is deprecated. Okay, let's use a version transaction, connection, send transaction with that version transaction. Cool. Okay. And then I can use this function, send version transaction with my connection. My instructions is just this one instruction. I'm just going to put it in an array here. In the signers goes my key pair. And I also, pretty sure, need to sign with my Merkle tree. Don't worry, I'm going to put all of that in a GitHub and then you can just read up on it. If that's the editing here is too quick, because I don't want to waste your time, yo. But essentially we just send a transaction as you normally would. The important part is this here, where we create our instruction. Well, let's see if that actually works. Console log me my signature. And then TS node, haven't done that in a while, me my create tree. Oi, assertion failed. We don't have a message. Cannot sign with non-signer key. That's the problem. So you don't want my Merkle tree to sign, but then are you sure that you can create the tree? Does the tree also need to be at a specifically derived address? Let's check that. No, the Merkle tree, literally, that's just a new key pair. Also in the test here. But it first creates that account already. So we manually need to do the system program create account. Before we create the tree into that account, we first need to create the account itself. Okay, so we need a system program create account. Fair enough, we can do that. And conveniently, there is a get concurrent Merkle tree account size. Oh, this is amazing. So we chose our pair and then we can just get concurrent Merkle tree account size from the SBL account compression program. And then we do a regular create account instruction. What does that return? Transaction instruction. Perfect. I mean, I could copy it from the test, but I always like to do it you know, manually like this, so I see what's happening really. Because if I just copy and then go over it, I'm like, yeah, it's all okay. But then sometimes I mess stuff up. So the new account pub key is my Merkle tree. The from pub key, well, that's who pays, that's me. The space is conveniently the space we got there. Could also apply the canopy depth. But I don't know the canopy depth. Apparently, if we don't specify anything else, we don't use a canopy. So Lamperts is then for the space, minimum balance for rent exemption. That's it. For some space. And the program ID, so that's the owner then of the account. Pretty sure I need to set that to the bubblegum program. No, the SBL account compression program. Okay. So that one belongs to the SBL account compression program, but the bubblegum is then using it. Maybe it sets itself as the authority on the SBL account compression tree. And then we still need to go through bubblegum where it saves the authority for the tree in the tree config, probably. Okay, perfect. So that's another instruction that we also put in here. We need to put it first, of course. And then let's try that again. Create my tree. Damn. Signature verification failed. Well, guess why? Because this time we do need the Merkle tree key to sign, of course. Let's go. One more time. Undefined. Because I, of course, don't return anything here. Should return my signature. But I'm pretty sure it worked and I just didn't, you know, get the signature printed. Let's check on Explorer. A minute ago, yes, got a signature. We did something, so that seems to have worked. Yep, created the tree, TRE, with 0.22221. If we round it up to Lamperts. And we've created this account, which is probably the tree config. Very likely this will belong to bubblegum. Yep. And the other one belongs to the SBL program. Compression program. Yes, cool. Yes, yo. We got our tree at this address, yo. It wasn't too expensive to mint that tree, right? 0.22 sol. Can afford that for 10k NFTs, right? And then we still need to account for the transaction fees for the actual minting, but that's like 0.00005 per NFT. So 5 zeros and 10k has also 5 zeros, so they each other, and therefore it's 0.5 sol that I have to pay for minting my 10k NFTs in transaction fees. I think my maths are correct, but my track record of getting my maths correct is not so good, so don't quote me on this either. Moving on. What else do we see here? Oh, we got the new program bombs out some data, and yeah, an empty Merkle tree. Looks good. We have an empty Merkle tree. So that's the preparation step that we had to do in order to now finally mint ourselves some NFTs. Next freaking step after creating mint v1. The instruction mints a compressed NFT. Note that Merkle proofs are not required for minting. Merkle proofs are not required for minting because we just add some new data. So we don't need to prove how it changes the previous data apparently. But that's good to know actually. We don't need to have a Merkle proof for just adding another one. Which is great because Merkle proofs are annoyingly big and complex. Let's check it out. We need tree authority. That should be fairly obvious because we had that. That's the same account as before. Tree authority as before, same thing. So let's get ourselves a create mint v1. Import that. Create mint v1. Or should we mint to collection even? Then we don't just mint an NFT, but we mint it directly to a collection. That's probably most likely what you want. Let's do that. Then it probably does the mint and the verify at the same time. Okay, so there we have all the stuff for the collection as well that we need then. But the collection is probably still a regular NFT. I wouldn't do the collection as a compressed NFT. Mint account of the collection, yeah, so it's a normal NFT that represents the collection. To do add collection tests. I don't want to get too far into detail here with how to create a collection, because I'm pretty sure we did that sometime. And I don't want to just mint myself an NFT without a collection. Well, I guess we need a create collection. Maybe I'm just gonna borrow Jonas's code here. Yeah, that's the classic metadata, token program ID, and create metadata account v3 instruction. That's what we'll need to do. He sets the size to 50 even though it's a million. Funny. Yeah, I'm just gonna borrow that code from Jonas. The SBL token was updated. Jonas used the old version, so I'm building it for the new one now. Just because. And just because I'll also use the non-deprecated one here. Doobie-doobie-doop. So that's all looks good. Collection metadata instruction. Metadata, mint, public key, payer. So, and then the details. Well, first, cNFT collection by Andy. Sol Andy. My name is Andy. Sol Andy. cNFT. And the URI. Well, what are we gonna put here? Let's see what we find. Andy NFT season 1. Back in the days. Metadata. Oh, it's even on Arweave. Back then I put it on Arweave. Because it doesn't really matter. I just put something there. Just so we have something. I'll put that here. Obviously you want to put your own data. Yeah, obviously. I'm just gonna reuse stuff because I'm too lazy to upload something new. Okay, moving on. Mutable true. Okay. Collection details null. Okay. And then we do the same for the edition. Create the edition, so that has another seed with edition. And then we create that as well. Okay, boom. All right. Okay. Collection size 10K. And then we pump that into a transaction. And there I'm too lazy to build a version transaction, so I'm just gonna skip pre-flight. True. No, we don't skip pre-flight. We wanna simulate it. Good. That's that. That's just a little detour that we had to take. Damn it. Incorrect program ID for instruction. What? Okay, that went through. Without those, it works, right? But something worked. What the? We'll figure it out eventually. Oh, maybe I'm just not waiting long enough. Could that be? But then the error really doesn't make sense. Now it went through. So yeah, I think we had a timing issue. We need to wait longer after creating the account and the mint before we... Okay. Anyway, gotta find that out. Doesn't matter, we have a collection now. Actually, now that we know how it works, let's make sure that we wait a bit longer. We gotta just wait, I don't know, 5 seconds here. I mean, those are always the annoying mistakes, or the error message leads you in a completely wrong track. It took a while, but we figured it out. Good that my editor can cut all of this out.
Sure, whatever you say, sir.
Or we could wait, we could do a finalized. That would even be better. I want finalized, please. While we're at it, let's create ourselves our collection. Add a vanity address. Collection. There we go. We get a collection for, anyway. Let's use this. All right, cool. Now that we figured out how all of this works and have a working script now, hopefully, actually didn't test, but with finalized, it should, wait long enough for... Essentially, the short version is I didn't wait long enough for the mint to actually be created, and then it didn't find the account or something. So I fixed that now, and I have a working script with which I can create myself the collection mint. Now that worked. Perfect. We now have a collection mint with this data. So let's actually check that on chain. There we go. First cNFT collection by Solandy. There we go. I'm the authority. That's the mint. That's the data. Good enough. good enough for a collection. Basically, I just want an NFT such that I can also have my compressed NFTs have a collection. Now that that's finally done, let's get back to our Mint1 cNFT, and we're gonna call the create Mint2 collection v1. So we're gonna create a Mint2 collection v1 instruction. Cool. Moving to the interesting stuff. This is alphabetical. Maybe let's go through it with the docs, because we doxed. If it was just a v1, then we had just those. So let's go through those first. The tree authority, that's gonna be what we derived here. Same. The leaf owner wallet, that will be the NFT owner. Well, so I just minted for myself. So the leaf owner, this is gonna be me. Then the leaf delegate, the wallet that will be the NFT delegate. Now, if we don't want a delegate, I think we also have to set this, but we just set it to the owner. So we again do ba-da-ba-ba-da-bop. Okay. Next up, the Merkle tree. That should be fairly trivial as well. That's the thing that we created earlier. The TRE. The payer who pays, well, that's also pretty self-explanatory. I'm just gonna pay because I got them funds. Then the tree delegate, the owner or delegate authority of the Merkle tree. So the guy who is able to write to the tree. We created a tree, we are the authority there. So again, this is us. So the delegate is also us. The log wrapper and the compression program, well, that's the obvious stuff. Again, SPL no op, SPL account compression. And that's all we needed for the mint. But we do a mint2 collection, so there's more stuff. What else is there? Collection authority, all the collection stuff. And even the token metadata program we need to put in because dealing with collection stuff. This is all clear except the bubblegum signer. There I'm not sure what it is. Let's maybe check here. Oh, that's creator, sorry, verify collection. The bubblegum signer PDA used when doing a CPI into token metadata to update the collection information. Well, let's go with the trivial stuff first. Collection authority. Either a true collection authority or a delegated collection authority. Well, let's use a true collection authority. Like us, because we created the collection. It's nice to do everything ourselves. That is literally just keep your public key for everything. What else? Collection authority record PDA. So in case of a delegated collection, this is the collection authority record PDA. And then if no collection authority record PDA, then it must be the bubblegum program address. Okay, so this collection authority record PDA is the bubblegum program ID. Sure. Collection mint. That's easy. Make a new pub key from this. It's the collection mint. Collection metadata account of the collection. Modified in case of a sized collection. See, that's why we need that and the token metadata program. I mean, who really uses sized collections? But yeah, that's actually even, fun fact, a feature that Metaplex is thinking of deactivating. Anyway, collection metadata. This one we can derive again, same way we did it earlier. Collection metadata account. We derive like this. Addition account, oh, that's the same thing, just with addition. Same, just with another one. Edition. Okay, the one that I know is the token metadata program. But this bubblegum signer, I still don't know what it is. Bubblegum signer, eh? Why not look in the tests? Nope, nothing. How did Jonas do it? Bgum signer, where does that come from? Collection CPI. I mean, you just gotta know this, right? You just gotta know. I mean, there's literally no word about that in the documentation whatsoever. Thank you, Metaplex. Anyway, we found it out. We found it. Thank you, Jonas, or whoever wrote this code. Just gonna use this. Just gonna derive with the bubblegum program collection CPI. This is the bubblegum's PDA that does the CPI into token metadata. Fair enough. What else are we missing here in this huge red thing? Of course, those were the accounts. Now come the arguments. Next huge red thing. Well, actually, metadata arcs is what? Interesting. The Merkle proof goes into the remaining accounts. Funny. Anyway, well, that's different arguments. Let's again see what Jonas did. Oh yeah, that was the part that I didn't understand. NFT arcs. What do the docs say? So, yeah, there we have also just the data, which is a metadata arcs object. Metadata arcs object is what now? This stuff. Okay, let's try and build it from this stuff. So, collection. It's easy, that's my collection mint. Creators, nah, I'm too lazy. How about none? Edition nonce is mutable. True. Name. There we go. That's something I can do. A cNFT. Primal sale happened. Well, whatever. Yes, it did. Seller fee basis points. I don't care. I don't need your money or my money. Symbol. cNFT. Token program version. Is all of that really compulsory? Can I token standard URI? There. URI. We can do this. I'm just gonna recycle the same one from earlier. Because I don't care. I just want some NFT. Oh, collection. Okay, collection is something else. Has a key. Okay, that's this. And a verified. True. There you go. It's missing the following from type. Edition nonce, token standard uses. So apparently I need to put all of them in. Annoying. Uses. Can I put null? Token standard. Can I put null? Edition nonce, I don't know, can I put null? Token program version, I don't know, can I put null? Original or token 2022, interesting. Okay, let's use the original token program version. Good, but that looks like that's sufficient for the metadata of the NFT that we mint. I mean, there's definitely gonna be some errors, I'm assuming, but with that, we create the instruction to mint to a collection, a compressed NFT. So let's see if we can send that. We just send the instruction and we sign it with our key pair. That should be fine. Okay, so that was the mint one. Let's see if we can mint a cNFT. No, we cannot, because redeclared variables. Come on, I mean, they're underscored. I'm not using them anyway. Bump 1, bump 2. There you go. You happy now? Try again and see if we can mint a cNFT. Oh, still not. Okay, we get a custom program error. Already verified. What? Collection item is already verified. I am doing something wrong. I mean, essentially, you're telling me I should say verified is false, such that you can then verify it? Maybe? Let's see. See, that's why we're doing this together for the first time. Because otherwise I could just go through the code and be like, yeah, you do this, you do this, you do that, all obvious. And then you are stuck with simple stuff like that. Ha! Ha ha! But see, that's all you gotta do. Then it works. Would I have realized that I need to set the verified to false when I go through this code? Hell no. And that's why I like to type it out myself to try and find the right values for myself. And then I find the wrong assumptions that I have. Like that I need to put verified true. No, you need to put verified false. Okay, we got a transaction out. Let's check that out on chain. So what happened here? We just paid for a transaction fee. Just one transaction fee. That's all we needed to pay for minting an NFT. And for the tree earlier, but you know, that's the cost for minting one NFT. Wow, nice. Now we have our collection here, we have the bubblegum program, we have our tree, we have the tree config. Let's see, mint to collection v1. That in turn calls the token metadata program, compression, append. So here we have an append to the Merkle tree, which again calls the noob. And there we have it. That's the output from the compression program that we know. It's an append Active index is 0, rightmost is 0, so it's the first one that is being added. Appending the rightmost leaf, yeah, it just always appends the rightmost. But the one thing that I got wrong is it's not starting at the right, it's starting at the left, but the rightmost leaf, you know, if it's the first leaf, then the very left leaf is the rightmost leaf. Yeah, anyway, so yeah, all success. All successful. Now, here we are again. We have minted an NFT and we're like, so now what? But by now, Solflare supports cNFTs. So just gonna put my wallet into Solflare. And we go to DevNet. And then, ta-ta-ta-ta. Wait, no. This is my 5? All right, yeah, I minted a few, I guess, because 4 of them I have minted in the process of creating a collection because it kept not working. One of them is the real collection NFT, the rest I could burn. And this is the one that I minted, that's a cNFT. All of those, I can check them out. I can go here and view them in Explorer. That's a normal token. So yeah, there, normal token. One of them that was minted. Another one will be the call. And this one, this guy, this is a cNFT that I just minted. And if I view that in Explorer, then we will see this is just the asset ID and it will not find anything here. For that, we need to again go through the read API and check out that thing, which we can do because we did that in the last video. And we can go by asset ID. This is my asset ID. And now I need the DevNet stuff again. And now if we read with the read API on DevNet, we get these. I said these. There we go. Some stuff. Response bad gateway. Oh, not good. I mean, that's one of the advantages of compressed NFTs. We rely on more infrastructure, those read API providers. Oh, there we go. That looks better now. Nope, gateway timed out. But anyway, we know that it's there. We know that it is a compressed NFT. Actually, let's mint another one, because that should be fairly straightforward. Now we should have another one. Here we go. We have 6 now. Quick, just another cNFT. So the minting works. The sending should also work. I could send that to wherever. Cool. But obviously letting the wallet do it is boring. Metaplex, bubblegum, transfer. We want to know how we do that ourselves. So let's go through the transfer as well. I mean, I'm assuming that that's going to be relatively straightforward as well. We basically just say which NFT, put in all of the authorities and programs that we need, and who's the receiver, and then we're good, right? So give me 10 minutes, 15, 20, maybe half an hour. Let's see. Transfer cNFT. Create transfer instruction. First, of course, we need to import that as well. Create transfer instruction. And again, we give a list of accounts. It's not even that many. Let's go through it with docs again, because I think that's the nicest way to do it. Transfer, here it is. I mean, all pretty straightforward. Tree authority, that's the same PDA from when we created it. Tree authority as before. The leaf owner, that's the owner of the NFT. Or the leaf delegate, I think we only need one of them. Either one of them needs to sign. Oh, and I need to know both of them though. I think the delegate is reset once I transfer. You know, I'm gonna try just putting the tree leaf delegate. So leaf means the NFT. Leaf owner, because that's currently me. And the leaf delegate, let's see what happens if I set it to null. The new leaf owner, so that's the recipient. Where do I send it to? Let's grab one of my Andy wallets. Andy. Then the Merkle tree, also obvious, that's the account where the Merkle tree lives. Log wrapper, compression program, you know, the classic. No op, compression. Okay, that should be it now. I can't keep the delegate now, that doesn't work. Okay, well, my public key it is. Then arguments. Now that's more complicated. Creator hash, data hash, index, nonce, root. Okay, that is indeed more complicated. So, the merkle root for the tree. Data hash. The hash of NFTs existing metadata. Without the verified flag for the creator changed. Aha, so that's for when we, with a transfer that doesn't change anything, but earlier when we created the one, there we had the verified flag set to true, so that hash should be taken when it's not changed yet, so when it's still false. Something like that. Creator hash of the existing creators array without the verified flag of the creator changed. Number used only once. This is the value of num minted stored in the tree config. And the index, that's the number of the leaf in the merkle tree. Okay, so there are a lot more complicated things now that we need. And it would really be cool if we had the read API to easily get them. Because the read API, I think, provides me with those values. I really want to get the read API to work. Jonas comes to help. Come on, Jonas. Hideous Helios. Definite. Come on. Helios, you got me. Invalid API key provided. Currently on the free plan. Yes, but you say it's an invalid API key. Index a code can be found here. No, that's not what I want. Helios compression example. Yeah, and then you have the connection string, RPC definite Helios with the API key. Aha. Okay, they have to handle it differently. Okay. Updating my wrapped connection a bit to work with Helios. Again, stuff that I just gotta do. Okay, so now we don't get the error anymore. Let's see what we get back here. Now that's already looking way better. Much better. Okay, so we just had to update our wrapped connection a bit such that it works with the asset key. Short version, just use the Helios example where you have that code that looks like this, and then it works with Helios as well. So, just in case the Metaplex read API provider is down or you can't manage to get it to work. So, we now managed to get the read API on DevNet. Thank you, Helios. They have a free tier. It's cool. It's good. It's good. I can get that with a free tier. So we have the asset ID, that thing, and we have the JSON URI that links here. Metadata is just the cNFT. That's the authority. So the authority is the tree config from the bubblegum. So the tree config PDA seems to also be the authority then for the tree. Compression, it is compressed. And see, there we have all of the nice data that we can just get from the read API, the creator hash and the data hash and the asset hash and the tree. Yeah. So let's hard code that just for a second. Just gonna use this. Yes, I would read it from the, we can read, should we, okay, persuaded. We also put that into our code. Fine. That's my asset ID. And then let's see if that works. Just the read API stuff. I'm gonna get you to work, don't worry. At some point, this is gonna work. If it takes me all day, which it does, at some point it's gonna work. But hey, it's about learning. We gotta learn on a Sunday afternoon. That looks better. That looks good. Nice. So that comes in an object, and all the interesting stuff is within compression. So compression. This is the unsafe part now, where we just take stuff from our object, so from our result here, and say compression dot there, creator underline, because those might not exist on there. I'm working on an any. That can be any. It can be that, or it cannot be. Let's just assume that that works. What else do we need? Data hash. Well, that is also in res. Compression data hash. Index. Well, I know that it's index 1, but where would that be? Leaf ID. There, that's the leaf ID, and that's inside compression as well. So that's leaf ID. So it's all there. You just need to know which is which. Then what else? The nonce and the root. Can we find any of that? Tree config account at the time the NFT was minted. Can be retrieved from off-chain data store. Yes, great, but where? Is it the sequence? Could be the sequence. I still don't get the difference between the leaf ID and this nonce. I'm just gonna guess, and I'm gonna be surprised if it just works, that this could be the sequence. I'm gonna mark it as with an assumption because I'm not sure about this, and if I'm like, oh, what's not working, then I wanna come back to this. So, and then we need the root. Oh, that's the merkle root of the tree. Can also be retrieved from off-chain data store. Well, great. And where? I would really like to have a description of what that is in the read. Well, there's documentation for the read API. Come on. That's a complex thing, eh? That's a cool graphic. I like it. I mean, great. We have the specification of what it should return, but not what that actually is. ID of the asset. Slow down, sheesh. Okay, why am I reading this? This is not helpful. What is the root? The root is on fire. Wait, but we did perform a transaction an hour ago. Oh man. Okay, so all the... No, here it is. Nonce, 0. Index, 0. Or maybe it's the same. Maybe I shouldn't take the sequence, but also the index. Maybe it is the same. Anyway, the root, well, that's just some random bytes. And by random, it's not random, it's a hash, obviously. But I mean, should we do another massive assumption and say, well, the asset hash, maybe that's the root. There's not much that I have to lose. Not much more that I can lose than more hours of my time. Massive assumption. And like, if we had that data, right, then that would be that's how we create our instruction. And if we had the instruction, that's how we would send it. So let's just try it. The worst thing is it doesn't work. So, okay. Doesn't work. Who would have thought? I would have thought. So, assertion error, array length 44 should match length 32. Okay, what am I providing wrong? This is complicated, and I can understand how sending compressed NFTs from a program is horrible. I mean, I can't even really manage from here. Okay, so there we have the length 44, and we expect 32. Guys, this is more complicated than I thought. Way more complicated than I thought. I mean, the minting was fair. The transfer... should have stopped after the mint. I need to really make a separate video about every freaking thing that you can do with those compressed NFTs, because it is complicated as stuff gets. Not to swear. Wait, but isn't there an example? So the RPC asset, that's what I have. Leaf nonce is the leaf ID. Okay. The root. Buffer to array. Asset proof dot root. Okay, so it gets all of that stuff from the asset proof. Data hash, that's the data hash. Base 58. First we need to decode it. And nonce and index are both the leaf nonce. Okay, that's at least something that we learned now. Get rid of this assumption. We take the leaf ID here. And those things we need to decode. Decode stuff. I'm getting lazy now. I'm like... decode my stuff. Oh, really? Really? That complicated? I mean, what do you need? A number array. Yes, you actually do need a number array. Wow. We get there. We'll get there. Decode this. Decode this. Index and the root. That's from the asset proof, the root. So we need to get ourselves the asset proof. Get asset proof, which is again from the wrapper. Get asset proof. Can do that. Okay. I mean, I could use a wrapped connection. Nah, I'm too lazy. I'm just gonna duplicate code. Duplicate code. Who cares? Quick and dirty. Don't use this at home. Well, or I don't know. Just There's a connection wrapper that's better than what I'm building here. So just be aware of that. So, but now we should be then also able to get an asset proof for my asset ID. Oh, and then you put all of that into the remaining accounts. You put the proof path into the remaining accounts. And if you have a canopy, then you can subtract the ones that you have already, so that the top level, the uppermost ones, they are on chain, and then you don't need to put those of the proof into the remaining accounts as well. Wow, this stuff is complicated. It's somewhat genius, but it's complicated. Complexity causes problems. But we need complexity for, cheap NFTs. Okay. Proof path for the remaining accounts, but let's leave that out for now and let it fail. The root is decode asset proof.root. Proof root. Let's see how far we get with that. Ooh, but that looks good already. It doesn't go through. Attempting to fill in proof, and then invalid root recomputed from proof. Yeah, either something is completely wrong, or we're just missing the proof, all of the accounts. So let's also do the thing with the proof path. Anchor remaining accounts, this thing, which is optional, those are the hash values that represent the nodes in the Merkle proof. Yeah, I guess they are also relevant. So I guess we shall provide them. I guess I'm not gonna calculate that myself. I'm gonna ask the read API. And I think it's part of this asset proof. Proof path is the map proof of the asset proof and the map proof. So essentially, we just wrap this. All this does, this map proof, is take the hash, pretend it's a public key, so put it in there in the 32 bytes, and say it's not a sign and it's not writable, because we need that for, the account metadata. So I'm just gonna borrow this function here as well. I mean, it's just a simple map where you add the sign and writable. And then those we put in the remaining accounts, right? And we slice it from 0 to the length. If there's a canopy, then we reduce the canopy height, which makes sense, right? If we have the canopy, then we don't need to put the remaining, so the last parts of the proof up to the root, we don't need to put that in because they are in the canopy. That helps us to save space in the transaction in those accounts. If we have huge trees, we need to build bigger canopies to not overrun our transaction size limits. But I don't know what my canopy height is, let's be honest. I have no fucking clue. So I'm just gonna provide all of the accounts. I'm just gonna put them all in. All in, baby. And let's see if that works. Woo! Let's go! We can do it! Been working with this for 5 hours now. Come on! Come on. I can do... Ooh! Haha! Jaw drop! I think I just sent an NFT. A compressed NFT. Wow. Yes, it was complicated. I mean, once you know it, it's not that complicated anymore. You just put in the right values and it all works. Right? So I could do a tutorial being like, oh yeah, and this is how you transfer an NFT. Essentially, you just call the create transfer instruction with the tree authority, the NFT owner, the delegate, and then where you want to send it, and that's the Merkle tree, and then that's the programs, and then you put in the proof in here, and the creator hash and the data hashes and the nonce, and then you send it, and then that's good. That could be a tutorial, right? That could be your 5-minute compressed NFT transfer tutorial, but I'm gonna do the 5-hour compressed NFT transfer tutorial because I just need to have all the details. We just need all the details to understand, if you understand what I'm saying. Okay, good. End of mental breakdown. Let's look at this. Let's look at my beautiful transfer. Yep, there, look at that. Those are all my accounts, and then boom, here, those are the hashes. Those are part of the proof. Oh man, yep, here that's all part of the proof. So wait, my depth was 14, so I would expect that 13 accounts I put in the proof path, right? Oh no, even 14, all 14. Okay, because I'm assuming it's the hashes and the root separately. So yeah. That's the proof. The root is separate. Leaf is probably the leaf is the asset hash, but that is not part of the proof. All a bit complicated, but yeah, okay, cool. Never mind. We managed to transfer. We managed to do a transfer. Means that our Andy should now have a compressed NFT. Yes, just a cNFT. Look at it. Look at it. I managed to transfer it all by myself with code. Look at all that code. I think I'm good now. I think my editor will be pleased if I stop now.
Thank you, sir.
I'm gonna end it here. Okay. We learned how to create a Merkle tree for the bubblegum program. Then we minted compressed NFTs. And then we transferred compressed NFTs. And it just took us 5 hours. All of the code I wrote today is in the GitHub, somewhere linked below, in case you want that. And it's a bit complicated, I admit. It is, yes. It's definitely not trivial. It is more complicated than it is with regular NFTs, because there you literally just call the token program to do a transfer. But there's no token program involved anymore. It's all just in the ledger, all just Merkle tree stuff. I miss the good old days where you could just send tokens around. My head needs a break now. I guess yours does too. And I will leave you a break before I can watch those videos. And subscribe and like the video and share it with all your friends who also want to learn about compressed NFTs. And then I will see you in the next video. Because the challenge would be to do compressed NFT transfers inside a Solana program. That's gonna be difficult AF. And it's a challenge for a future video. Until then, bye bye. Am I glad that I can go to sleep now? Good night.